Here is a slightly better presentation of the shape I was talking about. Those are the familiar numbers you see here. So this is how the Pascal's triangle can be constructed in 3D. But I emphasize one more time, the reason we are doing this is because we want to know how many ways we could pick three things of unlimited supply. Typically, these are three flavors of a candy or three colors of a tile, that type. So if you're picking nothing, there's only one way. If you're picking one of them, you see there are 1, 1, 1. You could pick one of each color. But if you're picking two, now there are 6 ways of doing it, you see. If you're picking 3, now there are 10 ways of doing it. You can count them. Then using these numbers you see there, you can even figure out the probability. See, this one is picking 3, so what's the probability of picking one of each? Here it is. There are 6 ways out of 10. How about picking only one of them? I mean, one color, 3 of one color. Then it is 1 out of 10. 3 of red would be 1 out of 10. 3 of blue would be 1 out of 10. 3 of green would be 1 out of 10. So very much like binomial expansion, you can use it, but except you got to kind of visualize in 3D. Typically, the math competition problems would ask you to pick 4 of them. So this is the triangle of your interest here. The key thing is that you got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 5 more says there are 15 ways of doing it. This comes up quite frequently. I've seen it several times. So here it is. So I showed you in such a way that you can reconstruct this even if you forgot. Just remember that these are just building pyramids and you just got to add one more row. So it's 1, add 2 row, you're adding one more rows of elements. So here you start with 1, then you add 2, add 3, because there are 3 of them, 1, 2, 3. Add 4, add 5, add 6, add 7, add 8, 9. That way you can construct the 10 choices problem in no time.